When we look at the Himalayas, we see the traditional symbols of permanence. To a human observer, these peaks appear fixed, immovable, frozen in time. In reality, this massive mountain range operates as one of planet Earth's most chaotic, volatile, and physically active engines. This engine generates the headwaters for the Indus, Ganges, and Brahmaputra, three massive river systems that provide the lifeblood for 600 million people. To understand how this geography sustains such a massive population, we have to look past the summits and examine a violent collision miles underground that is still happening right now. 70 million years ago, the Indian tectonic plate drifted northward at a rate of 20 centimeters per year, an absolute sprint in geological terms. When it eventually hit the Eurasian plate, the impact entirely closed the ocean that once lay between them. Because the Indian crust was too thick and buoyant to slide underneath Asia, it crumpled and stacked the rock into massive overlapping sheets called nappets. This continuous upward thrusting process is what built the highest peaks on the planet. This collision is not a finished event. The Indian plate is still pushing into Asia today at a rate of 67 millimeters every single year. The consequences of this pressure are observable at the surface. The mountains grow 5 millimeters taller annually, and the friction routinely snaps into devastating earthquakes. This relentless geological violence created a 2,400-kilometer wall of rock, so massive that it physically manipulates the planet's atmosphere. This wall creates an extreme spatial contrast, dividing a lush, wet south from a barren, dry north. During the summer, warm monsoon winds carry moisture from the Indian Ocean until they hit the southern face of the mountains. The mountains force this moist air upward, a process called the orographic effect. As the air rises, it cools rapidly and dumps massive amounts of rain on the southern slopes. The mountain wall simultaneously acts as a shield to the north, blocking freezing Central Asian air from moving south and keeping the Indian subcontinent uniquely warm. By the time the air crusts the peaks, it has been stripped of its moisture. This creates a severe rain shadow to the north, fueling the arid wastelands of the Gobi Desert. By manipulating the wind, the mountains trap immense amounts of moisture at extreme altitudes, fueling the next critical phase of the engine, the ice. Despite sitting near the warm subtropics, the 8,000-meter height of these peaks keeps them perpetually frozen. This region is known as the Third Pole. It contains 15,000 glaciers that store 12,000 cubic kilometers of fresh water. These glaciers act as a slow-release mechanism. They capture the heavy monsoon moisture and slowly melt, releasing it consistently throughout the year. This steady release trickles down the slopes to form and feed the life-giving river basins in the valleys below. This high-altitude water tower transforms sporadic, chaotic monsoon rains into a reliable water supply for civilization downstream. This complex engine dictates the surrounding biology, sustaining highly specialized ecosystems like the snow leopard, which is adapted to extreme altitude and rocky terrain. Lower down, the engine cultivates diverse biomes in the mixed forests, providing habitat for species like the red panda. This geographical power has even shaped the region's faiths, serving as the personification of Hindu deities and providing the sacred sites for Tibetan Buddhism. An engine only survives if all its parts function, and the climatic component of this system is now showing signs of significant stress. Over the last 50 years, overall glacial coverage in the Himalayas has plummeted by 13%. As the ice melts, massive glacial lakes are forming rapidly, creating an immediate threat of floods that could burst at any time. In the long term, the loss of this ice threatens to disrupt the timing and volume of the massive river systems that hundreds of millions of people rely on for survival. We are watching a fragile mechanism where physics dictate the weather dictates the ice, and the survival of the ice dictates the survival of the people.